Assalamualaikum and hi everyone. So our group will talk about application of logic in real life based on Kak Alam. Before we continue our lesson, first and foremost I would like to introduce our group members, which is myself, Aliana Midra binti Izani, Nurul Ain Syafiqah binti Raihan and Mariam Sakinah binti Zahran. Let's take a look what is contained in lesson outline. Introduction, example of mathematical logic ala operator, application of logic in car alarm system, summary and reference. Do you guys know what is the mathematical logic? So I will explain to you about what is the meaning of mathematical logic. Logic means reasoning. The reasoning may be a legal opinion or mathematical confirmation. We apply certain logic in mathematics. Basic mathematical logic are a negation, conjunction, and disjunction. This is the example of symbolic form of mathematical logic. Why we use mathematical logic? It equips us with critical thinking abilities, logical reasoning, and analytical skills. These problem-solving skills extend beyond mathematical equation and can be applied to various real-life situations, enabling us to tackle challenge in our personal and professional lives effectively.
Now, for mathematical logical operators, we use three, which is first, conjunction. This means and. Second is disjunction. This is mean or. And the third one is negation. This is mean not. Actually, there are five, but for this assignment, we just use three. Okay, so now let's see one by one. For the first one is conjunction. We can join two statements by an operand. It is also known as a conjunction. So this is a symbol for conjunction. In this operator, if any one of the statement is false, then the result will be false. If both their statements are true, then the result will be true. It has two or more input, but only one output. So let's see the truth table for conjunction. Okay, so now let's say the input are A and B. If the A is true, then B is true, the output will be true. If A is T, which means true, B is false, and the output will be false. If A is false, B is true, the output will be false. And the last one, if the output is input A is false, B is false, and the output will be false. So now let's see for the second one, it is disjunction. We can join two statements by or operand. It is also known as disjunction. So the symbol for disjunction is like a V. In this operator, if any one of the statement is true, then the result is true. If both the statements are false, then the result will be false. It has two or more input, but only one output. Let's see the truth table for disjunction. Okay, so let's say the A and B is input, and the for output is A or B. And T is for true, and F is for false. If input A is true, B is true, then the output will be true. If A is true and B is false, and the output will be true. In the input A is false, B true, and the output will be true. And the A is false, B is false, and the output will be false. So let's go for the last one, which is negation. Negation is an operator which gives the opposite statement of the given statement. It is also known as not, and this is a symbol for negation. It is an operation that gives the opposite result. If the input is true, then the output will be false. If the input is false, then the output will be true. It has one input and one output. So let's go through for the truth table for negation. Let's say the input is A and the output is negation A. If A is true and the output will be false, and if A is false and the output will be true. Car alarm. What is car alarm? A car alarm is a security system that helps protect a car from being stolen or damaged. It is designed to make a loud noise, like a siren or a horn, to alert the owner and scare away thieves or anyone trying to break into the car. The alarm usually goes off when someone tries to open the door, break the windows, or move the car without using the right key or having permission. Some car alarms also have extra features like sending a notification to the owner's phone or automatically locking the door for safety.
So now, let's take a look at the three main components in a car alarm system. Firstly, we have sensors. Sensors are a key part of a car alarm system, detecting unusual activity to trigger the alarm. We have three sensors overall, which is door sensors, shock sensors, and motion sensors. First, door sensors activates when a door is opened without the key. Shock sensors detect impacts like breaking a window, and motion sensors pick up movement inside or near the car. Together, they help protect the vehicle from theft or damage. By detecting these actions, sensors play a crucial role in protecting the car from theft or damage. Next, we have a control unit. The control unit is like the brain of the alarm system. It processes signals from the sensors and decides whether to activate the alarm. And it also manages other features like locking or unlocking doors, disabling the engine, or sending alerts to the owner. And lastly, we have the alarm siren, which is the part that makes a loud noise to scare off intruders and alert people nearby. It usually produces a high-pitched sound that repeats in patterns to draw attention to other people. And some systems also include flashing lights or honking the car's horn along with the siren. So next, let's take a look at the application of logic in car alarm system. We have three statements to determine whether or not the alarm will be activated. So, we let A represents the state of the door sensor. If it is true or T, then the door sensor will be triggered, and otherwise, if it is false or F, the door sensor is not triggered. So the same goes with the motion sensor and shock sensor. So we let B as motion sensor is triggered and C as shock sensor is triggered. So we use this mathematical logic statement to determine when the alarm system will go off, which is the statement A or B or C. So if either sensor is triggered, then the car alarm system will be activated. So now for more explanation, let's take a look at the truth table shown here. So we have A, B, and C. For the first row, we have true, true, true for A, B, and C, which is all three of the door sensor, motion sensor, and shock sensor is triggered. So then the output will be alarm will go off or alarm will be activated. So for the next row, we have true, true, false, which is door and motion sensor is triggered, but in the other hand, shock sensor is not triggered. The output will still be alarm will be activated. And then next, we have true, false, true, which is door sensor is triggered, while motion sensor is not triggered and shock sensor is triggered. Alarm will still go off for the output. And then next, we have true, false, false, which is door sensor is triggered, while motion and shock sensor both are not triggered. The output will still make the alarm go off. Next, we have false, true, true, which is door sensor is not triggered, while both motion and shock sensor is triggered. The output will be alarm will be activated. And next, we have false, true, false, which is door sensor is not triggered, motion sensor is triggered, and shock sensor is not triggered. The output will still make the alarm activated. And next, we have false, false, true, which is door sensor is not triggered, motion sensor is also not triggered, and on the other hand, shock sensor is triggered. The output will still make the alarm activated, but on the other hand, we have the last row, which is false, false, false for ABC, which is all three of the sensor, which is door sensor, motion sensor, and shock sensor, is not triggered. So the output will not activate the alarm because based on our mathematical logic statement, which is A or B or C, when all three of the statements are false, then the car alarm system will not be triggered. Now we are at the end of our lesson. So in summary, we can conclude that mathematical logic provides a structured framework for reasoning through concepts like negation, conjunction, and disjunction, which are represented in truth tables like we have seen earlier. So beyond theory, it enhances critical thinking and problem-solving skills with practical applications such as car alarm systems that use logical operations to process sensor inputs. This also highlights its importance in real-world contexts, including engineering and computer science, making it an essential tool for structured problem-solving and decision-making. So that is all from us. Thank you so much everyone for your time and attention. I hope this presentation can give you a clearer perspective and understanding on the role of mathematical logic in real-life problems. Thank you.